In this video, we're going to talk about different ways to relate sets of points. When I say sets of points, I just mean lines, line segments, and rays, right? Those are all made up of an infinite number of points. So we're going to talk about ways to relate those. Okay, so we have three ways we can relate these sets of points. We can talk about the intersection of the sets, the union of the sets, or we can talk about one set being a subset of another. So let's talk about intersection. Intersection, the symbol we use to talk about intersection looks like an upside down U, right? I like to think of it as an in because we have intersection. So intersection is the set of shared points. Maybe we should say it's all of the shared points between two sets. It's all of the points that both have in common. If we're looking at maybe think about a Venn diagram, the intersection would be this right here. The overlap of the points, right? So sometimes we think of that as and, right? It's in the first set of points and it's in the second set of points. It's in both. Let's do a quick example to show what that looks like. So here we have AB intersect BC, right? Where those 2 points intersect. So I have AB right here and BC right here. What point or points do those have in common? Well, they both share B, right? They both have B. So since B is in AB and it's in BC, then B is the intersection between line segment AB and BC. Okay, so that's intersection. Let's look at union. Union is represented by a U-looking figure for union. And it is it's best just to say it's all points in both sets. It's all of the points in both sets. So for example, again, if we were to draw a Venn diagram, the union would be everything in the first circle and everything in the second circle and everything that they share. The union is all of the points in both of the sets. So we would say that is like or. Because if a point is over here, well, it's either it's in this circle or it's in this circle, so it's in the union. Okay, let's look at an example. Ray FA union ray BD. So ray FA is right here, right? Going off into infinity. Ray BD is right here, going off into infinity. And it's the union, right? So it's all of the points that both of those rays have. Since they overlap and they're heading in opposite directions, well, we've got all the points going that way and all the points going this way. So that is any line defined on this line, right? Any line. So you could say AF, right? That's a good line to pick, but you could pick any line, right? Line BC, because remember, lines go on forever. So line BC, that's the same as line AF. Any line will work because all of the points are represented in this union of ray FA and BD. Okay, let's look at subsets. So a subset, it's kind of this sideways looking U, almost a C. A subset is when all points in one set are contained in the other set. When all points in one set are contained in the other set. So, for example, if we're looking at, it's a little tricky with a Venn diagram here, but this intersection right here, right, this little piece right here, oops, is a subset of this entire, let me get my colors right, of this entire circle, right? This, maybe we can like green or something. This right here, it still fits into that whole circle, right? Into this circle right here. But, yeah, but it's contained in that circle. So all the points in there are in that circle. It's a subset. So let's look at a true-false example for subsets. Okay, so for subsets, we've got, is AB, is that a subset of DB? Is the segment AB right here, oops, is the segment AB, is that a subset of DB? Well, are all the points in AB in DB? No, they're not. So AB would not be a subset of, AB would not be a subset of DB. What would be a subset of DB? Well, maybe you said BC could be a subset of DB, or CD could be a subset of DB. So those are things worth thinking about. Let's do a few more examples just to kind of continue to help you wrap your brain around this. We've got segment ED intersected with ray CD. So we have ED intersected with ray CD. Okay, so what set of points is that? What set of points is the intersection of segment ED and ray CD? Well, remember our intersection, that's where we have both, right? That's kind of where we've colored in both. So the intersection is segment DE. That's the intersection. It's all of those points contained with the segment DE. Let's, it's kind of messy if I don't erase that. So again, we said it's segment E. Okay. What about the union between BC and BA? What's the union between segment BC and ray BA? So remember, with union, that's where it's all of where we've colored in, right? It's all of the points. So for this, it would be all the points from C extending into infinity this direction. So that would be ray CA. Because ray CA goes all the way. It captures both of those sets. Okay, two more. What about line BC intersected with segment ED? So line BC, remember, a line is everywhere, right? Not a line segment, but a line. It's that whole, it's infinitely long, that whole set of points. And segment ED is this segment right here. Okay, And we're taking the intersection of those two. So remember, it's what colored in twice, right? It's both, it's where they overlap. So for this, well, the intersection of line BC and segment ED is just that segment ED. So what's another, what could we say? Oops. What could we say if we're relating segment ED to BC? We could say that ED, I'm just going to write this right here, ED is a subset of BC, right? Because all of the points in ED are contained in line BC. And in fact, any segment on here would be a subset of the line, right? Which is pretty cool. Okay, last example. Ray DC intersected with ray EF. So here's ray DC right here. And here's ray EF. And it's the intersection. But there is no intersection, right? There's no place where these two cross. So since there's no intersection, we say that that's the null set, right? Meaning it's the set that doesn't have anything in it. So for this, the way we write null set is just a circle with a line through it. It's the null set. No points are in the intersection of ray DC and ray EF. Okay, of course, I would encourage you to try some of these on your own, but I think that should give you a pretty good overview of what we're talking about when we're looking at the union, the intersection, and subsets of different sets of points.